By the time you're listening to this episode, the Metropolitan Museum of Art will have held its 2024 Met Gala, which is an annual event to raise money for the Costume Institute. If you're a follower of the Met Gala like I am, then you've already spent a lot of time scrolling through images of people wearing stunning clothes and judging how they fall in line with the theme of the event.
The gala also marks the opening of the Costume Institute's annual show, which this year is called Sleeping Beauties, Reawakening Fashion. The idea behind this exhibit is to showcase pieces from the museum's collection that are too delicate to show on mannequins. Instead, according to the New York Times, the exhibit will feature recreations of the pieces using AI and 3D techniques, along with sound and apparently even smell.
To be honest, I'm not entirely sure I can imagine what that entails, but when I go to museums, my favorite exhibits are the ones that feature clothing and textiles because I just think it's really cool to see the craftsmanship and imagination. So I'm hoping to get a chance to see this new show and how they approach it. And thinking about the idea of clothing that's too fragile to display had me wondering a bit more about the science needed to maintain my favorite exhibits. Welcome to today's episode of Tiny Matters. I'm Deboki Chakravarti, and I'm joined by my co-host Sam Jones. Today, we're answering a question that I've been wondering for a while now. How exactly do you preserve old clothes?
Textile conservation is what we in Boston like to talk of as where CSI meets MFA. So we're using forensic and traditional techniques to examine and understand historic artifacts, in my case, textiles.
That's Camille Breeze, the director and chief conservator at Museum Textile Services, a private textile firm in Andover, Massachusetts. And she works with a lot of different types of textiles, which are different objects made with cloth or woven fabrics. We've done a few episodes about forensics on Tiny Matters, though we're usually talking about how investigators use chemistry or trace DNA to study crimes. But it turns out that understanding any individual textile is its own mystery. To start, think about just how many different types of things are made from textiles.
So on the average month, I might get a Civil War flag, a christening gown, an embroidery made in the 19th century, or I could get something that is cherished by a family.
For conservators to figure out the best way to work with a given piece, they have to be able to understand how it was made. But like we can see from Camille's list, that's a lot of different types of objects that all have their own histories, and some of those histories take time to uncover. So let's start with the basics of how textiles are made, beginning with fibers.
So the key element of that fiber is it needs to be able to create a structure, create a filament, a yarn, a thread, something like that.
With a few exceptions, fibers can be put into one of three categories: plant, animal, or synthetic.
So take plant fibers, for example. Sometimes we get the fiber from the flower of the plant. So think of a cotton boll. All that fiber is a remnant of the flower, the fruiting body. Then we have the stem of a plant. Things like rope are often made of the long fibers found in the stem of, say, the flax plant, where linen comes from. And the job of the stem is to grow long and strong and to hold the flower out where it can be found. So the fibers we get from that are long and strong.
In addition, Camille told us that you can get fibers from the veins of a leaf. And then there are animal fibers, like wool or leather.
And you can imagine that if I had those choices and I was an early human, I would probably start with something that I got from an animal. I would start with a pelt. And that doesn't necessarily need assembly or sewing. You can just use it as is. You can lie on it. You can lie under it. You can make something like a sling to carry things with.
And then last of all, we have synthetic fibers, which are made by humans through chemical processes. For example, polyester is a synthetic fiber that's usually made from petroleum. But fibers are just the beginning. You also need to assemble them, which is its own feat of engineering.
So the first textiles humans made were single element structure. You'd take one thread or yarn or cord that you've made by spinning other cords together to get a fatter cord, and you'd make sort of a net like a fishnet.
Camille told us that over time, people figured out ways to make more complicated structures, like using 2 needles to knit. And another major advance was weaving, where you have one set of threads in one direction and another set passing over and under those threads to produce a woven fabric. This would be considered a 2-element structure.
In addition to crafting fibers and creating more complicated structures with them, people have also been incredibly inventive in how they personalize these textiles by using dyes or embellishments like feathers or embroidery. And all of that is just to make the textile. From there, the textile becomes something, maybe a garment or a flag or some other item. And part of what I find so fascinating about all of this is that we've basically been writing our own history into these objects that we use every day. The challenge for conservators is to read into the way those objects are made to see if we can uncover that history.
Every object is its own journey, and we can't always answer the questions that are being asked of us. I have a dress right now that is associated with a famous woman whose husband was a Revolutionary War general. And so I've been asked to confirm or disprove whether this dress could have belonged to this person. So it's not really a question of whether I can prove it. It's whether I can eliminate it from consideration due to date or material or technology or anything else like that. But fortunately, all museum work is teamwork. And my information is combined with other information like historical record or photographs in some cases. And that's all put together to make a decision based on what we believe to be true now.
There are a number of techniques that conservators can use to better understand the pieces they're investigating. One of those useful things to know, of course, is what the fibers are.
Let's take flags. We get lots of flags. Many of us can tell whether a flag is silk or maybe wool or cotton just by looking at it. And when we can't, we will take a tiny fiber sample and use our microscope and confirm the fiber content.
To learn more about how conservators study these objects, we talked to Susan Heald, a textile conservator at the Smithsonian's National Museum of the American Indian.
I love fiber ID. We have a polarizing light microscope, and I usually just try to take the tiniest amount of fiber, but representative. And then under the microscope, you don't get any chemical information, but you can see the fiber morphology, like looking at the difference between cotton and linen or flax. Linen is the fabric, flax is the fiber. You can really see that they have a very different morphology, and synthetic fibers are even prettier because you get color, interference patterns.
So after looking through the microscope, the next step is to understand how the fibers were put together to create a structure, which Camille told us can come down to knowledge and experience. And that can lead to a lot of really interesting questions and educated speculation about the object's history.
So if something is made of silk, I ask myself, what would silk be good for and where would it fail? If you're carrying it on the battlefield and it's got a big heavy fringe and it's got all these painted areas, I can predict what kind of damage it's going to get on that battlefield and even what damage is going to occur when it comes back and it's rolled on its staff and it's put in the attic of the library and found 100 years later. So some of that can be predicted based on technology and materials, but everything is unique. You could find for example, writing that you can't see with the naked eye, but you can catch in a photograph or under a black light. And that writing might be a name, it might be a date, or it might be a note as to why something was saved. And in that way, we've been able to reconnect objects with stories from the area or from the family by sort of matching the technology and the date of the object with details in that story.
Susan told us about a few projects that she's been involved in to understand the techniques used to make different objects. And she emphasized that these are very much collaborations involving chemists and conservation scientists who bring a lot of their knowledge to the work. In one project, Susan was working with a doctoral student on quill work from the eastern woodlands. They were especially interested in the dyes that were used to create the brightly colored quills that might then be sewn into a hide to create patterns in a moccasin or woven together into a headdress.
One of the techniques they used to study the dyes was liquid chromatography mass spectrometry, or LCMS, which allows scientists to separate out compounds in a sample for identification.
And she broke it down into different colors. What were the plants and what were the components of the dyes that she was finding? And one of the interesting things that she found were the blues that were largely, a portion of them were from wild berries like currants and grapes. She was finding those markers for those berries, both in the red and the blue.
In another study, Susan was part of a team that wanted to answer what had become a murky question. Was dog fur used for blankets made in the Pacific Northwest? These blankets were made by the Coast Salish peoples, who have a long history of working with various animal fibers, like wool from mountain goats, along with plant fibers like hemp. Oral histories from the Coast Salish also referred to a local dog whose hair was used in these weavings. But in the 1980s, one study on these textiles in various museums couldn't find any dog hair fibers, which threw that history into question.
So Susan's team needed a way to extract and study proteins from small samples gathered from the National Museum of the American Indian and the National Museum of Natural History. When they got their samples, they dissolved them to extract the proteins and then identified them with another type of mass spectrometry called protein mass spectrometry. With this technique, scientists break up proteins into peptides to identify them.
We took very small samples and analyzed them and just basically found that, yes, we did find dog hair in the earlier pieces. But as you see the Europeans coming in and trade goods coming in, the whole system was disrupted. And maybe those special dogs were, got bred into the greater dog population and more trade materials were available. And so some things were just lost.
The National Museum of the American Indian also features a number of contemporary objects that show how garment making methods have evolved over time.
The majority of collection, because it's archaeological and historical, are natural fibers. But, the more and more the contemporary things we collect, there's more and more synthetic fibers and plastic materials. Maybe 10 years ago, there was a powwow outfit, powwow regalia. It was like a 29-piece outfit that was just elaborately beaded. It was collected in the early 2000s, I think, but probably made in the late 80s, early 90s. And we noticed inside the vest that there was a lot of deterioration on the interior, and it said it had been made with a cotton cloth, but it didn't really look like a cotton cloth. And we looked really, really close under the microscope to see what we could find, and it looked like it was a composite material, like something rubberized that was fragmenting, but it also did look like a woven cotton surface. So we were asking some of our colleagues that are bead workers and makers of powwow regalia, and they're like, yeah, well, sometimes people have used the rubberized flannel that you see in baby lap pads or mattress protectors.
Baby lap pads are waterproof cloths that people use for various baby-related needs. And Susan learned that lap pads were starting to be used more in the 70s and 80s in place of traditional tanned hides because they were cheaper and less labor-intensive. But as they dug into the chemistry of the substitute material, Susan and her colleagues found that this particular piece of regalia had plasticized parts. And as people moved and danced in the powwow regalia, that component was actually deteriorating.
Susan told us that she's learned that people are now moving away from this material because it doesn't seem to have very good longevity. And actually, that brings us to another very important fact. Textiles don't necessarily last that long. I'm sure we all have some precious piece of clothing that got stained or chewed up by moths or something else. And obviously, that's a huge challenge for textile conservators.
There are a number of potential threats that conservators have to take into account, some of which are really hard to avoid, like light. If you see something fading on your wall, you might think, oh, I should take that down because I don't want it to get damaged. But as Camille told us, if you see fading, it's probably already a bit late.
Physical change, like fading, is an indication that your textile, in this case, has already undergone all sorts of negative processes. Heat, like sunlight that passes every day at a similar time, causes the things that the light shines on to expand and contract with heat. So first of all, we have things expanding and contracting, which can, over time, weaken them. And then you have all sorts of things like free radicals interacting through the air with your object, and you can stop deterioration with something like a UV light filter. But that doesn't stop the heating and cooling. It just takes away the UV portion of the visible light spectrum.
In addition to light, you also have to worry about humidity and heat because they can catalyze some of these negative reactions and also potentially lead to issues like mildew. And then, of course, There are pests. Some of the common critters they deal with are moths, beetles, and silverfish, but sometimes they come across some more unique ones. Camille told us about a torn-up coat that a museum had brought to her. The museum suspected a tourist was responsible, but Camille wasn't so sure.
I said, "Do you have any rodents on this little island in the Atlantic Ocean?" And they said, "No, absolutely. There are no mice and no rats. There was just the one muskrat that swam out to the island once that was caught." and I pointed out how all of the damage in this coat was in these little semicircular shapes, and that this had in fact been nibbled, been perhaps taken for a nest.
So you've got light, temperature, insects, and sometimes even rogue muskrats to worry about. Those are a lot of conditions to manage, and there are plenty more that conservators have to take into account when working with pieces. So as Susan told us, there's a lot of research and planning before they even start.
And one of the first things I do is to research the background, to know where it came from, who made it, what's the cultural context, what's the importance of this item within the community. And as I'm putting all that together and researching maybe online or within our collections database, I'm also starting to assess the condition. So taking all that into consideration and sometimes doing analysis like fiber ID to figure out what are the fibers in this textile and how have they been procured. Maybe it's a nylon fiber, or maybe it's like a cellulose acetate. And I wouldn't want to use any acetone solvent around that because it's going to dissolve if there's, stain removal. And a lot of things we sometimes look for is pesticide contamination, because a lot of, especially natural history collections and collections like ours that have fur and feathers and wool, a lot of those items have been treated with pesticides like arsenic, especially with furs, which is, of course, toxic.
So after taking in all of these details and ideas about how the piece is meant to be exhibited, Susan will write a proposal detailing how she's planning to work with the object. That proposal then goes to a curator for approval, as well as a supervisory conservator and possibly a community member who might be an expert in making regalia.
And once they begin working with the item, Susan and her team maintain careful documentation. They take pictures before they do any interventions, keep track of their process, and then take pictures at the end of any changes that have happened. But sometimes things don't go according to plan, and conservators have to respond quickly to find a solution. Susan told us one story about when her team was washing a white sail with a large red emblem in its center that had been tested for dye fastness, or how well the color resists fading or running.
And we were washing out some staining, and everything was going well, and I had surfactant in the water and it's going well, and we decided to go rinse it, and we were rinsing it with deionized water, which is ion starved and very reactive. And all of a sudden, once the surfactant was gone, that red started to just bleed, like the color just lifted out and was going into the water. And I got really freaked out because, well, water is such a powerful solvent, but deionized water is so much more powerful and aggressive. So we turned off the deionized water, we switched to the tap water, the municipal tap water. We continued rinsing, the dye bleed lessened, but then we had to come in with blotter paper and try to absorb all the colorant from the dyed element in the center.
It took a lot of people working very quickly, but eventually it turned out okay. And this is one of those cases where the issue was very obvious. But there are other more mysterious challenges that can come from surprising sources, like museum exhibit cases.
Well, you go to a museum and you see all these exhibit cases, and we tend to construct the exhibit cases really tightly, so there's not very much air exchange. You don't want any dust to get in. You definitely don't want any moths or pests to get in that could eat your collections. But at the same time, if you have these really, really tightly built cases, you can have off-gassing components on the interior.
Off-gassing is when materials release chemicals. For example, it's why new cars smell the way they do. They're releasing different compounds from all the different parts used to make the car. But that smell goes away because you're opening car doors and allowing air to flow in and out. Museum cases are built to do the exact opposite of that. And that became a problem with a particular set of cases because they relied on a structural adhesive that's strong enough to glue metal to glass. And as the glue was off-gassing, one of the compounds it released began causing issues.
It's reacting with the objects themselves, and it's causing crystals to form on the object surfaces. And it's really interesting because it's on a lot of variety of object surfaces. It's on ceramics, it's on feathers, it's on stone, it's on some textiles, but not others.
While they still don't know exactly what's going on, Susan is part of a team that's using a number of techniques to study these crystals so they can figure out how and why they're forming and how to deal with them.
Like any other field, textile conservation is always evolving. One of the important advances has been that thanks to modern techniques, scientists and conservators can take smaller samples from their objects and sometimes even turn to non-destructive tests that allow them to learn without causing any damage to the original item. For example, Susan told us that they can use X-ray fluorescence analysis to look for heavy metal pesticides that might affect how safely they can work with the piece. There's also larger shifts in how museums and conservators approach working with these collections.
I think a lot of museums are doing more collaborative work with communities, Indigenous communities, any communities of origin. And I think that's becoming more important. But back 30 years ago, it wasn't so common. I remember, giving some presentations in the mid 90s or late 90s and having people, tell me that wasn't appropriate. I think times are changing, and I think this is all being considered a lot more seriously, working in partnership.
Camille also pointed out that there's more conversation and consideration about the types of clothing that are being collected and how that impacts our understanding of history.
More often now, we're understanding that the people who we've collected artifacts from are only a certain percentage of the population. Your institution might have a whole bunch of Gilded Age gowns, but nothing that belonged to, say, the serving class that enabled those people to live their lush life. And so what I enjoy is creating a costume exhibit where there is diversity in not only the type of garments that we show, but the type of people that own those garments. We might make a mannequin that has more than one tone to indicate that you've had a diverse population, or include a piece of clothing that belonged to somebody that was differently abled in some way. Just as humans come in an endless variety of the skills and shapes and special qualities, we are very much invested right now in creating dress displays that are extremely diverse in how we represent the human form in human history. And that's a really big change from the last, say, 20 years.
And it matters that we evolve how we work with these textiles because how we preserve our history shapes the way we understand it.
Preserving human culture is so key in our understanding, not just who we are now, but who we have been and then who we can be in the future. And so because textiles, they go everywhere we go. We communicate with them, we rely on them, and we use them as symbols. To me, they are just the most intimate artifact of all.
You see on a lot of these garments and textiles that have been actively used and loved, they have signs that show how they were worn and how they were used. Sometimes you can tell if a person was right-handed by the soil on the cuffs. So I think they can serve as witnesses to history. They serve as teachers for all of us. I mean, they have so much to tell us about the individual and about the community and about the artist who made these with such care.
It's Tiny Show and Tell time.
Sure is.
Today, I am bringing you a story that I read in Science Magazine, and I thought it was really fascinating, plus a little bit gross and a little bit alarming.
Perfect.
So it's really got everything for you. Okay, so around 7 years ago, there were a group of researchers. They were in the Budongo Forest Reserve in Uganda, and they saw these chimpanzees scooping dry bat feces, also known as guano, from under a hollow tree and eating it. This was a first. They had never seen this. And I don't know if you know this, but bat feces, it's actually quite rich in nutrients, but it's also rich in a lot of viruses. I think we all, over the course of the last few years, have learned that bats are carriers for many viruses, but this is a very interesting potential link that we didn't necessarily consider for a lot of viruses in the past, from bat to chimpanzee or, monkeys, apes to humans. So then these researchers were like, okay, is this just a really weird occurrence that we saw, or is this something that's actually happening more often? And so what they did was they put cameras in the tree where the chimps were actually scooping up this guano and eating it. And they found that there were chimps coming and eating guano at least 92 times on 71 different days. And then they found like monkeys were eating it. They found that black and white colobus monkeys, I think that's how you say it, also ate guano over 60 times. And then they also even saw like antelopes eating it, which I thought was really interesting. And so what they decided to do then was to actually analyze the guano. And they did find that in addition to having pathogens, right, like it was actually really rich in a lot of essential dietary minerals, sodium, potassium, magnesium, phosphorus. So typically chimps and these other animals are getting it from the raffia palm. But from 2006 to 2012, tobacco farmers in the area ended up having to use a lot of that palm because apparently there was a big surge in demand for tobacco. And so they actually, they made this string from the palm's leaves to tie up tobacco leaves for drying. Those palm leaves were no longer available. When the palm disappeared, chimps, monkeys, antelopes, they had to look for other sources of these nutrients. And so eating things like clay and bat dung seems to be what they turned to. So this is partially a result of deforestation.
Yeah.
We don't want our very close relatives eating bat poop because it's just going to make it more likely that you have some sort of zoonotic disease that reaches us.
Wow. So this was like a completely new behavior. Do they know for sure that it's because of this palm that like got deforested, or how do we know that we just like weren't missing it before?
It's hard to say 100%, right? Like it's hard to show cause and effect here for the palm being gone and them eating bat guano. These are monkeys that, or rather, these are like chimps and like other apes that have been studied for a long time, and no one's seen this before.
Yeah.
So it
seems
either we just completely missed it, or this is something that is just wasn't really happening before, at least not to this degree, and now they're really seeing it. It was interesting, though, in the story, an outside researcher who was commenting says that, in the future, a team should actually analyze not just the bat guano, but the chimp species as well to really confirm that they are ingesting these viruses that are passing through their gut and are really hanging out long enough to infect them. Because, I mean, it would be great if they were ingesting this guano, but they weren't actually really being infected. Maybe the viruses are not as active at that point, whatever it may be. So, like, this is not, I don't want to be an alarmist with this. I do think it is important thing to keep tabs on and to know is happening. But it is true that a lot more needs to be done to really actually show that this could be as dangerous as they're saying it could potentially be, if that makes sense.
Yeah, for sure. That's super interesting. And also, yes, gross, like you promised. For my tiny show and tell, I also have an interesting animal observation. And this is an article from the New York Times about menopause in whales. And so the thing to know first about menopause is that as far as we know, it's pretty rare in animals. So in most species, the female of the species will make eggs through to the end of their lives. It seems logical from an evolutionary standpoint. You want to make more of the offspring. Obviously, we are a species where that is not the case. And chimps also, there's menopause, but there are 5 species of whales who go through menopause. For example, apparently female killer whales can breed up to around the age of 40, but they can survive into their 90s. So this is overall fascinating because like it leads to this fundamental question of like why? Like why menopause? Why does it happen? Is there some kind of evolutionary advantage to it? And so this article is about a recent study on why menopause might potentially help a species overall. And so the scientists on this study, they used pre-existing data on these 5 species, as well as some related species that don't go through menopause to kind of do some comparison. And one thing they found is like, so in general, whales have this pattern where the bigger they are, the longer they live. But in the species that can go through menopause, female whales actually lived an average of 40 years past their predicted lifespan. So to the researchers, what that actually suggested is that menopause is not the result of mutations that are like reducing how long they could reproduce. Like it's not like they could live that long and and then you're kind of backing away on how long they can reproduce. It's really actually years that are added on past when reproduction would stop. So like somehow the menopause is actually like correlating to like living longer. And then if this is the case, again, this is still like a lot of kind of conjecture. There is a question of like why this would be potentially advantageous. And so one of the ideas is that maybe this means that you could have older females in the population who are not competing with their offspring in giving birth, but they can still be helpful. So like in these whale species in particular, like this corresponds to observations of older female whales who lead pods on journeys and stuff. And so the scientists involved speculated that this like might be a feature, like menopause might be a feature that evolves in species where females tend to stay in the group for a long time. But again, we still know so little about the evolution of menopause, but I just thought it was interesting.
No, that's so fascinating. We're learning more and more about how other species, in particular other mammals, are just so similar to us. So there's this part of me that's like, I feel like there's dozens of other mammals out there that this happens to, and we just don't know yet.
Yep, for sure. Because I think you're totally right. And it's also still fascinating to me that it is so hard to find species that go through menopause. Like it is still weirdly so rare. And I guess like there's something about that that maybe makes sense. Like I said, like it feels like there is a logic to this idea of like, if you can just keep reproducing until you die, like why wouldn't you do that from an evolutionary standpoint? I mean, it sounds like bleak when I say it out loud like that, but like from an evolution standpoint, seems to make sense. The thing that's interesting to me about this, and also like where it becomes complicated because you never know how strongly you can take these results, is like then how this kind of corresponds to the way these animals, including us, structure societies, because that's like part of the implication here is like maybe this is about these female whales stick around longer in the population and like they're able to kind of take on a certain role. And so, yeah, I'm not always comfortable fully being like, yes, this is why the society is this way. But it is like an interesting facet, this intersection of biology and like just how we live.
Yeah, it absolutely is. Thanks for tuning in to this week's episode of Tiny Matters, a production of the American Chemical Society.
This week's script was written by me and was edited by Michael David and by Sam Jones, who is also our executive producer. It was fact-checked by Michelle Boucher. The Tiny Matters theme and episode sound design are by Michael Simonelli and the Charts and Leisure team.
Thanks so much to Camille Breeze and Susan Heald for joining us. Remember, you can send us your science stories, science factoids you love, science news you came across and just cannot stop thinking about, and maybe you'll hear it read aloud on an upcoming Tiny Show and Tell Us bonus episode. Email tinymatters@acs.org. You can find me on social at SamJScience.
And you can find me at Okidoki Boki. See you next time.